Okay, alright. Morning. Assalamualaikum warahmatullahi wabarakatuh. For those Muslim, we start our online class this morning with Surah Al-Fatiha. Okay, we continue our discussion in topic of deterministic model of inventory control. And in the previous class, we have discussed about the quantity discount model. And we address in the quantity discount model, there are two approaches in solving the problem based on the data that we have. For example, for data that holding cost changes based on the unit price, we will use a quite complex or a long process in determining the order quantity. But for the holding cost that is fixed, we have a simple approach in determining the quantity or the cost. And this morning, again, we discuss under the topic of price quantity discount model, but we focus the changes of cost in the ordering cost. When the ordering cost is changes based on the volume of order. So, for example, here, Pasir Enterprise use 4 tons of fine industrial sand every day, and this sand costs 20 ringgit a ton to buy and 1 ringgit 90 cent a ton to store for a day. Deliveries are made by modified lorries which carry up to 15 tons, and each delivery of a load of part load costs 200. We need to find the cheapest way to ensure continuous supply of sand. So the data show that the more quantity that we buy, this will impact to the ordering cost. Ordering cost also will increase aligned to the number of trip to do the shipment of sand. So we need to understand the data and produce a meaningful data to be analyzed. So we can summarize the information in the previous slide. So the reorder cost will be 200 ringgit for each lorry load, and order up to 15 ton need 1 lorry with reorder cost of 200, and order between 15 and 30 ton need 2 lorries with reorder cost of 400, and order between 30 and 45 ton need 3 lorries with reorder cost of 600, and so on. So we have also information about the daily demand at 4 ton a day and holding cost at 20 ringgit a ton, and holding cost at the unit price at 20 ringgit per ton, and holding cost is 1 ringgit 90 cent a ton a day. So taking the lowest cost curve with the lowest ordering cost of 200 ringgit. For the lowest ordering cost of 200 ringgit is only valid for quantity order of less than 15 ton. Jadi kita tengok di sini dalam kes ni kan, kita ringkaskan maklumat pada slide sebelum ini yang mana kita dapati bahawa reorder cost-nya adalah 200 dan setiap pesanan 15 tan kita perlu menanggung kos pesanan sebanyak 200 dan sekiranya pesanan yang kita buat adalah di antara 15 hingga 30 tan, maka kita akan memerlukan tambahan pengangkutan lori iaitu 400. So maklumat juga diberi di situ bahawa kita mempunyai permintaan harian sebanyak 4 tan sehari dan unit price kita adalah RM20 jadi 1 tan dan holding cost kita adalah RM1.90 untuk 1 tan per hari. Baik. Dan langkah yang pertama adalah untuk melihat kepada ordering cost yang terendah. Dan ordering cost yang terendah kita adalah pada S, ordering cost bersamaan dengan 200. Dan sekiranya kita hendak pada ordering cost iaitu 200, maka kita perlu membuat pembelian yang kurang daripada 15 tan. Okay. So, taking the lowest cost curve, the ordering cost at 200 only valid for ordering quantity Q less than 15 ton. So, using the optimum order quantity model to find the optimum order quantity, so we replenish all the information into the formula and the result show that 29 ton is not valid, is invalid for the ordering cost of 200 because 29 ton is more than 15 ton. So when we calculating the total cost, the Q must be replaced with the lowest quantity of valid minimum ordering cost at 200. So here we replace Q with the quantity of 15 ton. So we find the first point here at 147.58. Remember that when we do the quantity model, discount model, we need to include the fixed cost. The fixed cost is the unit price multiplied with demand. So the unit price here is 20 ringgit multiplied with the demand, daily demand. Here we have 4 ton. So plus with the variable cost, include the ordering and holding cost. The next step is to identify the next lowest cost curve at ordering cost of S equal to 400. And for ordering cost of 400, it is only valid for the quantity order between 15 and 30 ton. So based on the optimum order quantity formula, we found that the order quantity will be 41 ton. And this also invalid for the ordering cost of 400. So taking the lowest minimum order quantity need to be ordered is at, taking the maximum taking the maximum order quantity based on the data provided is at 30 times. At 30 times. So we replace with the value Q here with the maximum order quantity of 30 times. So the second step, show the point B at 161.83. We need to repeat this step until we get the valid minimum. So the next lowest cost curve is S at 600. And based on the optimum order quantity, we have 50.3 tons, and this also optimal order quantity also is not valid for the ordering cost of 600. Based on the data provided, and we replace the Q with the maximum quantity that should be ordered for the ordering cost of 600. So we replace Q with 45 times, and we get the point C at total cost of 176.08. And next, the lowest cost curve is ordering cost at 800. So at 800, the optimal order quantity is 58. And finally, we get the valid minimum. The valid minimum order quantity. So the Q will be follow the odd quantity. The Q will be follow the optimal order quantity. So we replace information of we replace the data into the total cost formula. So the point D is 190.27 ringgit. So we have 4 points here, A, B, C, and D, and we need to compare the total cost that we have, and based on this, it shows that the point A has the lowest total cost at 147.58. So the best choice is to order 50 tons at a time with delivery needed every 3.75 days. So kalau kita tengok kepada rising delivery cost, hampir sama proses dia untuk yang kita bincangkan sebelum ini. Cuma bezanya apabila kita dapati bahawa valid minimum tersebut, apabila nilai optimal order quantity tersebut adalah tidak valid, kita menggunakan nilai kuantiti yang paling maksimum untuk mengoptimalkan penggunaan ordering cost kita, kan? Untuk mengoptimalkan ordering cost kita. Jadi berlawanan sedikit dengan kuantiti diskaun yang kita bincangkan sebelum ini, yang mana kita mengambil kuantiti yang terendah di dalam julat yang ditawarkan. Tetapi untuk pricing delivery cost, kita akan ambil nilai yang kuantiti yang maksimum untuk memaksimumkan ataupun kita kata nak mengoptimumkan kos yang kita tanggung dalam ordering, dalam membuat pemesanan. Baik. Jadi kita dah habis bincang berkaitan dengan quantity discount model yang mana kita telah pecahkan kepada quantity discount model price tu tadi, dan juga pada hari ini, pagi ini kita bincangkan berkaitan dengan rising delivery cost. Baik, Model seterusnya yang kita bincangkan di bawah deterministic model adalah production order quantity ataupun finite replenishment rate. So the next model that under the topic of deterministic model is production order quantity. This model has suitable to be used when the rate of production is greater than demand. When the rate of production is greater than demand. So based on this assumption, the goods produced at the certain process will accumulate at finite rate while the line is still running and produce the component needed by the next process. And this model concerned with the stock of finished goods at the end of the production line. So the main assumption in this production order quantity assume that a single item may be considered in this model, and demand is known, constant and continuous, and also cost also known exactly and do not vary. And we take the basic production order quantity model, so there are no shortage are allowed. In more advanced production order quantity, we will allow the shortage to be included in our decision. So replenishment of stock often occur at finite rate rather than instantaneously. So it means that the order quantity is received gradually over the time. So that's why the demand or the goods that receive accumulate at the certain rate in the production order quantity model. So the purpose of this analysis is to find the optimal batch size. The optimal batch size. Especially when the production rate is greater than demand. Other significant objective of this model is to find the total cost, production time, cycle time, and the perfect time to place an order. So we need to modify the formula of economic order quantity. So the new economic order quantity based on the production order quantity as follow: Q equal to square root of 2 multiply demand multiply with ordering cost divide by ordering cost and multiply with the square root of production divide by production minus by demand. So an inventory system in which an order is received regularly and an inventory is simultaneously being depleted, also known as a non-instantaneous receipt model. Assume that Q is received all at once is relaxed. So the P refer to the daily rate at which an order is received over time, also known as production rate. D represent a daily rate at which inventory is demanded. So production order quantity model answer how much to order, when to order, allow partial receipt of material, suitable for production environment, material produced that used immediately in the production line, and provide the production lot size information, the suitable, the optimum size lot, provide the optimum size lot. Lower holding cost than economic order quantity, and Uh, so this figure show the inventory level where the supply of the goods begin and ends, and when the demand period take over after the production has been done. Okay. Then we see the example of production quantity model problem. Yeah. Okay. For example, we have an information. We have information of problem regarding to the production quantity model. So we have carrying cost here or holding cost here is 75 cents per yard, and setup cost. Okay. Normally in the production or the production quantity model, we did not mention ordering cost. We state as setup cost to suit the production environment of in organization. So the demand here is 10,000 per yard, and daily demand based on the working days that we have 311 days per year. So we divide the annual demand with the annual demand, and we get the 32.2 yard per day, and the production rate is 150 yard per day. So based on the formula of production order quantity to determine the batch size, we include the information or the data to be replaced in this formula to multiply with the setup cost of 150, multiply with the demand 10,000 demand per year, divide by holding cost 75 cents, and multiply with the 1 minus 32.2 divided by 150 of production rate. As shown in this formula, the demand rate, the daily demand is smaller, smaller compared to the production rate, to allow the production quantity model to be used to solve this problem. So the results show that the batch size is at 2,256.8 yard. So we calculate the total cost, and based on this formula of total cost, show that the total cost is 1,329 ringgit. So we just replace the information into this formula. For example, here we have setup cost of 150 multiply with annual demand of 10,000 divide by Q optimum batch size 2,256.8 plus with the holding cost or carrying cost multiply with the optimum batch size and divide by 2 to get the average cycle inventory, and multiply with the 1 minus daily demand divided by production rate per day, and we have 1,329. So the important information here that we have, we can determine the optimum batch size for the production environment. So organization or company manufacturer can use the information to set the batch size quantity to be used in the production process. So the production run, the period of production run, Q, optimum batch size divided by production rate, daily production rate, 2256.8 divided by 150. So we have 15.05 days per order. So the production process we're running to finish the batch size of 2256.8 yard within 15.05 days. Baik, berdasarkan production run ni kan, dia bagi maklumat bahawa proses pengeluaran tersebut akan beroperasi kan, selama 15.05 hari untuk setiap pesanan. Jadi dalam tempoh tersebut, tempoh ini adalah tempoh masa untuk menghabiskan kuantiti dalam satu batch iaitu 2256.8 ya. Number of production run, berapa kali kita perlu kita kata membuat pesanan ataupun perlu kita buat setup pada mesin kan. Kita perlu buat setup ataupun kita berapa banyak batch yang kita akan ada kan, iaitu kita tengok di sini demand bahagi dengan optimum order quantity. Kita akan dapat 4.43. So the number of production run here is annual demand divided by optimum batch size. So we have 4.43 runs. So based on this information, we conclude that the number of order will be 4.43, and also it provide information about the number of setup at the machine. So we knew that there will be 4.43 setup to be set up at the machine. And the next is the maximum inventory level. To get the maximum inventory level, Q multiply with the 1 minus by daily demand divided by production rate per day. So we have 1772. So based on this figure, the maximum inventory level will be at here. So let's say we have maximum inventory level 1772 based on this figure. We have the maximum inventory level here 1772. So the production run, so we have the production. Number of production run 4.43. So we have this jaws teeth. We need to develop this we need to develop this curve with 4.43 4.43. 4.43. So to show the numbers of production run. Numbers of production run. So the period of production run show in this finding is 15.05. So it takes 15.05 to finish one cycle or one batch of inventory. So this production order quantity is very useful to be used in determine the lot size in the just-in-time implementation. As you remember that in the just-in-time, we have small lot approach to support the successful of just-in-time. So to determine the small lot approach, we can use production order quantity to identify the best small lot to be used in the just-in-time. We have another example of production order quantity here. For example, we have a demand for item is constant at 1,800 units per year, and the item can be made at constant rate of 3,500 units a year, and unit cost is 50 ringgit, and batch setup cost is 650, and holding cost is 30% of value a year. What is the optimal batch size for the item? If production setup time is 2 weeks, when should this be started? So, based on the problem that we have here, we need to understand whether to use the production order quantity model or to use economic order quantity model. Sorry, EOQ, economic order quantity, or to use economic order quantity. So to determine whether to use the production order quantity or economic order quantity, we can find in the problem here. Normally for the production order quantity, they will provide information about the production rate. We provide about the production rate, and the term ordering cost will replace with the term of setup cost. So this will signal to us to use the production order quantity as the best or more suitable model to solve the problem. So we take out all the data from information given here. The demand will be 1,800 per year, and the production rate is 3,500 per year, and the price per unit is 50 ringgit, and the setup cost is 650 ringgit per batch, and the holding cost is 30% from the unit price, equal to 50 ringgit unit per year. So this is the variation to determine the optimum batch size formula, variation of formula to determine the optimum batch size, where the Q equal to square root of 2 multiply with demand multiply with setup cost divided by holding cost and multiply with the square root of production rate divide by production rate minus by demand. So the optimum batch size here we have 166.7, and for the production run or production time here, Q divided by P, so we have 0.16, and the 0.16 is equal to 8.4 weeks. How do we get 8.4 weeks? We assume that in 1 year, we have 52 weeks. So 0.16 year multiply with the 52 weeks. So we have 8.4 weeks for the production time or production run. And the cycle time is we replace the information here. We have 0.3. The production time is the production process. The duration of the production process. So the duration of production process is 8.4, and for the cycle time for the production run here, we have 0.31 year 0.31 year or 16.4 weeks. 16.4 weeks. So we replace the data into this formula. 2 multiply with 650 divide by 15 multiply with the 1,800 and multiply with the 3,500 divided by 3,500 minus by 1,800. So we have 0.31 year. To get the duration in week, so we need to multiply with the 52 weeks. So we have 16.4 weeks here. And for the variable cost, based on this formula, so we complete the solution for this formula, and we have the total cost for this problem at 4,129 a year, and the total cost which include the fixed cost of unit price multiplied with the demand. So the total cost include the fixed cost is 94,129 a year. So we can find the reorder point level also based on the information that provide in the problem. 2 weeks to set up a production, and the time to start production can be found from the calculation of the point level here, where the reorder point level equal to the time multiplied with the demand. So 2 weeks multiply with the demand here, 1,000 daily demand here, 1,800 divide by 52. So we have 70 unit here. So then the best policy that we have is to start making a batch of 567 unit whenever stock fall to 70 unit. Jadi kalau kita tengok pada curve tu, kan, apabila inventory berada pada paras 70 unit, kita boleh memulakan proses pengeluaran menggunakan batch yang seterusnya, iaitu satu batch sebanyak 567 kan. 567. Okey. Boleh faham? Ada soalan tak sebelum kita lihat pada slide yang seterusnya? Okay, reason for variability in production. Most variability is caused by waste or by poor management, and the specific cause include employees, machine, supplier, produce unit that do not conform to standard and are late or are not proper in the proper quantity. And the variability also caused by inaccurate engineering drawing or specification. And variability also caused by the production personnel that try to produce before the drawing or specification are complete. So normally the production personnel done this to do the pilot test on the new product. So, and the last reason why is the variability occur in the production process is due to the uncertainty or unknown demand from the customer. So that's all for today. Under the topic of deterministic model. So on this topic, we learned that there are two approach. There are two approach or two model to mitigate the problem exists with in the condition of known demand with the sum of information about the uncertainty in the cost related to the inventory control, which include the changes in the holding cost, changes in the ordering cost. So how we adapt these changes in the practice to take the advantage of quantity discount price provided by the supplier, and also to solve the problem regarding to the changes of ordering cost, and also to solve the problem regarding to the determine the batch size in the production environment. So that's all for today. If there is no question.
Sir?
Yeah?
Sorry to interrupt. Sir, as I heard, are we having a quiz on Thursday?
Yes, we're having a quiz. Okay, I would like to make an announcement that we're going to have a quiz on this Thursday, this coming Thursday. What the date on this Thursday? Apa tarikh pada hari Khamis ni? 12. Okay. On 12 November, we will have a quiz 1. We have quiz 1. And the quiz will be online for the whole day on apa tadi? Berapa bulan? On 12 November. I will open the quiz 1 for the whole day of 12 November. So you can take the quiz whenever you have a free time on that day. And the quiz will cover the topic 1 until 2. Chapter 1 and chapter 2. And the question is about 15 multiple choice question need to be answered online. And what the other information? Yes, that's all. So we have a quiz on Thursday, 12 November. The quiz will be open for the whole day. So I will provide berapa kali attempt lah kamu nak? Saya akan bagi 2 kali lah attempt kan. So there will be 2 attempts to answer the first quiz, quiz 1. So the numbers of question is 15 multiple choice questions that cover chapter 2 and chapter 1 and chapter 2 only. Oh, berapa minit? Kalau 15 soalan. Oh. Satu soalan, 1 minit sempat?
Tak sempat, sir.
Sempat lah. Berapa minit?
Ada
30?
30.
30.
So ada pengiraan kan soalan dia?
Pengiraan. Saya rasa ada lah sebab fokus apa nama tu? Kita ada fokus kita tu kan? Tengoklah nanti ada soalan pengiraan ataupun tidak. Simon pun saya tak bagi ni pada kamu. Okay. So there will be 15 question and the duration of the quiz will be, is it enough if 25 minutes?
Yes. Boleh.
Ya, 25 minit ya. Kalau bagi panjang-panjang sangat nanti 30 minit, 35 minit nanti kamu bincang sama kamu kan. Hello, jawapan nombor 1 apa dia? Kan. Betul kan macam tu. Okay. So 15 question we need to be answered within 25 minutes and 2 attempts for the 15 multiple choice question. Okay. Any question regarding to the quiz 1? Ada apa-apa soalan tak untuk quiz 1? Apa lagi yang kamu nak tahu? Saya yang tu je lah, kan simple je kan. Okay, kalau tidak ada apa-apa, kita akan tamatkan kelas online kita pada pagi ini lah. Bagi yang beragama Islam, okay, saya akan buka lah. Saya akan tinggal kepada kamu untuk attender lah yang belum. Bagi yang beragama Islam, kita sudahi kelas kita pada pagi ini dengan